everybody able to make the equations? Find the zeros. I didn't give you anything with the radicals in it. I didn't give you any conjugate pairs. Can we try one with a conjugate pair now? Okay, so I wanted you to practice with this last night. And all I wanted you to do was to leave them in factored format. If you leave it in factored format, I'm okay with that. Right, so if you left it like this, but you need to make sure you set it equal to something. It's not an expression, it's an equation, it's a function. So it has to be set equal to that or to y. Set it equal to something. Okay, let's try one now with the conjugate pair. So we're going to have roots of 3, 2, and 1 plus or minus radical 5. So, how many roots do I have altogether? 4. I took a plus or minus, right? So let's start with the basic one. Bring this out. X equals 3. X equals 2. Okay. So flip them back to factors. Good way to start. Now, these are my conjugate pairs. I have x is equal to 1 plus radical 5. I have x is equal to 1 minus radical 5. I cannot multiply those two things together. I can do, if I want, I can do x minus 1 plus radical 5 times x minus 1 minus radical 5. If you want to FOIL this, you're more than welcome to. It works. It takes a little bit of time because you got a radical in there and it'll work itself through. Or we can use your sum of your roots, negative b over a, and we can use your product of your roots, c over a. And you're going to have to know those. We did those in Algebra 2. That's going to set up the little quadratic that I need to use. So, easiest way, in your calculator, put these guys in with the plus sign in between. Let your calculator do it. The radical 5s are going away, so the sum is 2. We're going to let a equal 1 because we can't solve one equation with two variables. So we're going to let a equal 1. Therefore, if 2 is equal to negative b, what is b equal to? If I solve for positive b. Negative 2. Good. Now, in your calculator, change that little plus sign to a multiply. Let your calculator do this part. It's your perfect squares. 1 minus 5. This gives me a negative 4. Again, we let a equal 1. So now what is c equal to? So our quadratic is x squared minus 2x plus 4. So we're going to make our final equation. And you can leave them all in factored form. Oops, that's a minus 4. Minus 4. I don't have an eraser. Oh, there you are. Thank you. Okay? Just you didn't have it for homework last night. I just thought we'd throw it in. Do you have your homework?
No, I don't.
Just that part? Did you have yours?
No, I tried some of it though.
Okay. All right, so we good with this part so far? I could multiply these guys out, but you don't have to.
Wait, why do we have to put, why do we still have to put x is equal to 0? Like it's not equal to anything.
So if you forgot x and you went to go do your roots, you'd only have 2. You would lose your x of 0. X is technically 0. It's technically x minus 0, which gives us x. Right? Yeah. If we didn't put it there, we would lose that altogether. That's why you can never divide by an x. You can never get rid of your x's. Okay, so let's take a look at these guys. Then my goal was so that you get your inflection points and you get your concavities. Okay? So they gave it to you already in factored form. Let's take a look at this. Our highest exponent is x cubed. The coefficient is positive. So we've got an odd one. They behave differently. A positive says down on the left, up on the right. So I know it's going to look like this. If I find my zeros first, I should be able to plot my zeros and figure out my sketch. Did you guys try finding it without graphing it? I'll always let you use your calculator, but I want you to get used to trying it. Visualize what it's looking like and where we're going with that. Okay, so we found our zeros. We noticed x squared, so if we took the square root, and yeah, you're right, we can't take the square root of 0, but that's your double root. Your regular root passes through, your double root bounces off. So a nice way to show a double root. Now, we said 3 roots, 2 terms, 1 inflection point. Here's your concavity. Here's your concavity. This piece right here is making a cave down. Agree? Do you spot any other caves? You have a cave up. So this piece over here says cave up. Now the ends are fine, but they shared this middle. So halfway through, we're going to let them share it. That's called your inflection point. It means you started concaving one way, and then you say, whoops, I think I'll go up now. So your inflection point is a midpoint.
The relative minimum and the relative maximum?
Absolutely. Absolutely. Excellent. We take your relative maximum, x, and your relative minimum, x, and we take the average. So 4 plus 0 divided by 2. So it's got an x of 2. Negative 4 plus 0. So it's got an x of negative 2. Now, go to your calculator. Go to second calc, second trace, give me the calc. Number 1, value. Put in x is negative 2. That will find you this y value. An inflection point needs an xy. In this case, yes, it works out that we can take the average of the y's, but sometimes our graphs are off and we can't take the average of the y's. Just go straight to your calculator and you can do it. Once you find the inflection point, now you do your concavity. I concave down from negative infinity to that x point. Then I changed my mind. From that x point to infinity, I concaved up. Does it make sense? Yes? No?
We need a list, that's all.
We need a list. I didn't tell you what to find on this?
It just doesn't describe completely.
Oh, okay. All right. Sorry about that. You kind of realize you have to do your max and your mins to do increasing, decreasing, or concavities, right? So you had to get that part. All right, let's try another one. Okay, my highest exponent, if I multiply them out, is t to the 4th. And I'm a negative coefficient. So negative, the even ones either go up together or down together. Negative is like my quadratic, negative x squared. They go down. So my ends will behave down. And I will have 4 roots, 3 terms, 2 inflection points. So I've got 4 because these 2 are doubles. I got 2 double roots. Again, separate these. They're already factored. So separate them. 1/2 I can get rid of because I can divide. I set it equal to 0. I can get rid of it. Here's your double roots. Okay? And double roots cause your graph not to go through the axis, to bounce off the axis. So if I knew I was here at the negative 4 and the positive 4, and my ends both went down, they've got to bounce off like this, somewhere around there, they got to turn, right? They got to make a little turn here to come up. I have to have 3 turns. 1, 2, 3. Somewhere I made a W. Do I know how far down? No, but my sketch shows me I have some kind of upside down W. When I put it in my graph and I find my mins, and this is my relative min, because my range goes all the way down, 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 down. We have no min there. We have an absolute max, but a relative min. You're going to have to change your window. Can everybody change their window? Not on your phone, on your calculator. On your calculator, yes? On your calculator. If you need to push it down, that's your Y min. If you need to move it up, that's your Y max. Mins and maxes on the Ys, I always find kids get confused with, because it works kind of weird. But you're pushing down, change your Y min. Find your inflection points for me. Here's my concave, watch. Here's the concave down. Here's the concave down. Do I have any other concaves? I have an up. I have a concave up that shares these points. So I'm going to let them share by giving them half each. So I find the midpoint from these values. And again, I'm pretty fortunate that my midpoint was easy to find. 4 plus 0 divided by 2. That's only the x value. Put it in your calc, find your y value. Okay? Then do it for the other side as well. Now, this one had symmetry. This one had symmetry across the y-axis. So if you kind of found one inflection point, you can kind of find the other one by using symmetry. This guy, is it an even or an odd function? Not depending on the exponent. Is it even or odd? If I have symmetry across my y-axis, am I an even function or an odd function? Even, good. If I can replace the t with a negative and still come out to be the same, then I'm even. It has nothing to do with your even exponent and your odd exponent. Well, it's kind of in the long run it does, but. So your concavity, I'm caving down from negative infinity until I hit this point, negative 2. Then I changed my line from negative 2 to positive 2, I caved up. Then from 2 to infinity, I caved down. That makes sense, doesn't it? Okay, is this our last one? No. Second to last one? Okay. Alright, I have an odd function, and my coefficient is positive. So I have 3 roots, 2 terms, 1 inflection point. My end behaviors say down on the left, up on the right. All that without even putting it into your calculator. Now you put it in your calculator, and again you can see symmetry because if I put in my negative x, it comes out to be exactly the opposite signs. Therefore, if I took out a negative 1, I'm an odd function, so my symmetry is through the origin. And I can see my symmetry through here. Can you see your symmetry? All these do kind of tie into place. Can you find your relative mins and maxes? Okay, relative mins and maxes, factor, take out an x, don't lose that x, that's your 0. These guys, positive and negative 2, there's your zeros. Cover this, my y-intercept is 0, because I have nothing here, plus 0. Okay, so now I know all my intercepts, I know my max and my mins, I can do my increasing, decreasing, and now I can do my concavities. I have a cave down, and I have a cave up. So they share that point. And nicely, since it's through the origin is your symmetry, it's right at the 0, 0 is your inflection point. So I'm concaving from negative infinity to 0, down, and then up from 0 to infinity. Makes sense, right? Increasing and decreasing work off of your max and your mins, but they still use your x values. Concavity works off of an inflection point, and it still uses your x values. Although you can have a concave with just a parabola like this, you can concave up from negative infinity to positive infinity. You can concave up. Because that doesn't, it has two roots, one turn, no inflections. So it makes its own natural, kind of natural cave. Okay. And now one more. Oops, still more? Oops, one more, if I can get down there. All right. All right, this one had a lot going on. How are we with this? We're good with this? We're not good with this. All right, let's work this out. I want everybody doing this. If you don't have it on your paper, I want you doing this with me. So you're going to start here. This is an x squared. This is an x. This is an x. So an x times an x. What's my highest exponent? 4. My coefficient is 1/5. It's even. So where are my ends behaving? Up. Okay, I know that. So I have 4 roots, 3 terms, 2 inflections. Okay, I'm going to start here. It's already factored for me. This is in factored form. How nice is this to set this equal to 0? I can get rid of my 1/5. I can set each one of these to 0. Do I see my double root because of my square? This is my double root. This means this will bounce off, not go through. Then I've got 2 other roots. And I can kind of estimate where my 4.5 comes in. So I graph. There's my -1. There's my 3. There's my 4.5. I bounce off of this, turn, and come up. Put it in your calc. You'll see it. I've got all real numbers for my domain. I've got a relative min. I can find it in my table even, or on my calculator. I have a relative max. You're going to have to find that in your calc. And I have an absolute min. You're going to have to find that in your calc. Don't use trace. Make sure you use second calc max and second calc min. Trace does not work for you. Once in a while it will find the turning point, but not 90% of the time, no. So can everybody find their max and their mins? So we can do increasing, decreasing, right? From our x values? Okay, so concavity. Let's take a look at your concavity. Here's a cave up. Do I have another cave up? This cave's up. Do I have a cave down? Smack in the middle. Cave down. So they share these. I like to label my graph. So I labeled point A and point B as inflection points. I do like to put my minimums and my maximums there, and it really doesn't interfere with the rest of the graph because I like to look at those when I'm doing increasing, decreasing. I think it's easier to look at that than have to find the point on my paper and then try to figure it out. But my inflection point, just label it. It's smack in the middle of your graph. It's a lot to put there. So I take this min, -1, and this max, 1.262, and I find its midpoint. I put it in, I find its midpoint, and I get 1.131. Now, I go to my calculator. I do second calc value. I find its y value. I let the calculator find its y value. This is point A. And yeah, it's kind of right around that x, that y axis there. B, I'm going to take this side and this one. So 1.262 plus 3.863 divided by 2. I'm going to get 2.565. I go to my calc. I let it find my y value. The only reason why you need the y values is because an inflection point is an xy point. I just need to have the y. Do I make reference to it ever again? No. But I need to have the y. So my concavity says, start at negative infinity. I'm going to concave up till I hit this point. That's the x value for my inflection point. So from negative infinity to 1.31. Then I decided to concave down between those two inflection points. And I took that inflection point and I concaved up. Good? Questions? Getting a lot of blank faces here. You guys need to talk to me a little bit. Normally when you divide, you do a long division. Normally your long division says, if I want to divide 123 divided by 9, what do I do? How many times? I go like this, right? I say it goes in here once. I multiply down. I bring down this guy. How many times does it go in again? I multiply down. Then I have a remainder. Sometimes I say remainder, 6, back in when I was little. Then I learned to make a fraction, right? And when we checked it, we said, oh, multiply 13 times 9, and then add your remainder. Oh, and I come back to my original number. We can use long division for this as well. And long division for this says, take x plus 3 and divide this into x to the 4th minus 10x squared minus 2s plus 4. I need a little space holder where I'm an x plus 3. And I can do this whole thing out, long division. It's long, it's cumbersome. So instead of doing long division, we use synthetic division. Yeah, we're not going to do it long division. Instead of doing that, because this would take us, we would have to go like this. X goes into x to the 4th, x to the 3rd times. We would have to bring this down. Plus 3x cubed plus x to the 4th. Then you got to subtract both of these guys. Then you got to bring down your next term. And you keep on doing this again and again. And you can absolutely do it this way. But we have synthetic division. Now, what synthetic division does is it takes out all your leading coefficients. Write this down. All the leading coefficients. But I have to account for every single place. So I have an x to the 4th. Do I have an x to the 3rd? No, so I have to put a 0 there. I have an x squared, I have an x to the 1, and this guy is technically x to the 0. So I have all my x's now. So I'm pulling out my coefficients. 1, I need a 0, negative 10, negative 2, 4. And you're going to make a little L like that. You're going to do what they did. 1, 0, negative 10, negative 2, 4. I want you to work this one with me. Okay? And then this guy has to have a leading coefficient of 1. Same kind of thing when we completed the square. If not, I have to factor it out. It does. So this is a factor. I want to set my factor equal to 0 so I can find my root or my 0. That's what I divide by. That's how they set it up. Now it's set up for you. So we're gonna work this through. Everybody see where that came from first? Okay. First step through, bring down the 1. Always bring whatever's here. Bring down the first position. We are going to multiply from the left and bring it to the right, and then add down. It's just a pattern. Multiply left, bring it to the right. From the left to the right, from the left to the right. So, so of course you need a starting place. So we bring down this first guy. So what is negative 3 times 1? Negative 3. Okay, now we add down. 0 plus negative 3, negative 3. Now, from the left to the right, what is negative 3 times negative 3? 9. To the right of it. Now I add down. What is negative 10 plus 9? Negative 1. I'm not at the end yet, so I multiply left to right. What is negative 3 times negative 1? 3. I add down. What do I get? 1. I multiply from the left to the right. What is negative 3 times 1? Negative 3. I add down. 1. Now, here's the tricky part. What do all these things mean to me? They are my coefficients of my answer. And I could also have a remainder in there. Maybe it didn't go in evenly. It doesn't have to go in evenly. When I divide, don't I sometimes get a remainder? If I was a factor, then I would get no remainder. So, start like this. You divided the highest exponent in the numerator by the highest exponent in the denominator. Right? We did this long division. X to the 4th minus blah, 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 and x plus 3. I just want to look at the highest exponent in the numerator and the highest exponent in the denominator. So x to the 4th minus x to the 1. So I say, what is 4 minus 1? 3. This guy is going to start with x to the 3rd. So I go like this. Let me move this up. This is very tricky, but stay with me here. I say x3, x2, x1, x0. Can I go any further down than 0? Nope. Then this is my remainder. It's going to start backwards at x0. So here's my answer. 1x cubed minus 3x squared minus 1x plus 1, and a remainder, we're just going to say, make this into a fraction, plus 1 over, I divided by, x plus 3. I like to put these guys in parentheses so it doesn't interfere with my remainder. Yes?
So if it's a remainder, you're just going to have 2x and 0?
Well, it's going to be like, if we have two places, we would have an x0 and an x1. We'll do a remainder, a bigger one in a minute. But if it's just divided by one set, you're going to have only one position in your remainder. Sometimes you have a little more than one. This is our answer when we did this division. It's just a pattern. Let's try another one. The more you try them, the better that they get. Okay. Now, before we try this, I want you to cross off the 3 for me. I want you to cross off the 3. I just want to divide by x minus 2. And then we're going to do the 3x minus 2. So this time around, pull out all your leading coefficients. 6. Okay, I'm going to check. I started with x3, x2, x1, x0. I have them all? Good. Okay, now, is my leading coefficient 1? It is because I made it, right? So this is my factor. I'm going to set this equal to 0 so I could find the 0 of my equation. I put that here.
Wait, what would happen if we kept the 3?
We're going to do that next. But I just want you to get the pattern first. So now, we have no place to start, so we bring down the first guy, 6. Okay, we multiply from the left to the right. What is 2 times 6? 12. I put it here. I add down, negative 4. I multiply from the left to the right. What is 2 times negative 4? 8. Negative 8, right? I add down. What do I get? 9. I multiply from the left. What is 2 times 9? 18. Add down. 12. Okay, now, front end. My highest in my numerator was an x to the third. My highest in the denominator was an x to the 1. Say it real simple. What is x to the third over x to the 1? X squared. So this guy's going to start with an x squared, then an x1, then an x0. Oh, he's my remainder. So here's my answer. 6x squared minus 4x plus 9 plus 12 over my denominator, x minus 2. Now if I multiply this guy, 6x squared minus 4x plus 9 times x minus 2, and then I added in 12, I would come out to what I have on top. A nice way to just check is just to eyeball your first position. 6x squared times x is what? 6x cubed. Okay, do the last one. 9 times negative 2 is what? Negative 18. Well, I'm supposed to get negative 6, but I have to add in my 12. What is negative 18 plus 12? Negative 6. If you do the first position and the last position, that's a good check, rather than have to multiply the whole thing out. Really, guys? Okay, now we're going to divide this with that other denominator. Okay, we start by taking out the coefficients. 6, negative 16, 17, negative 6. We start out the same way. I didn't need that big of a thing. But my leading coefficient is not 1. So just like we do when we complete the square, we have to factor it out. So I want you to circle and put a star next to what we factored out. Then you're going to take this guy and set it equal to 0. So x is going to be equal to 2/3. That's what I put over here, 2/3. We're going to have to factor it out, because it has to be 1. And I just want you to asterisk, put a circle, and I'll show you why at the end. So now, we start by bringing down the 6, because we have no starting place. What is 2/3 times 6? 6 times 2 is 12 divided by 3. 4. Okay, add down. Okay, what is 2/3 times negative 12? Negative 8. Add down. What is 2/3 times 9? 6. 0. The 0 means that this is a factor. But now watch. If we started and we multiplied 6 times 3, we get 18, don't we? Because we have to now take this 3 and divide everybody by 3. Guys, let's finish this up. So 2, negative 4, 3. So now, 2 times 3 gives me 6. If I was x cubed over x1, this is going to start at x2, x1, x0. So my factor is 2x squared minus 4x plus 3. Okay, does it make sense?
Wait, why did you divide by